Welcome back. In our previous video sessions, we have studied derivation of Euler's formula for columns for different constraints. Right? Four different cases we have studied for different end conditions. Now, I'll be generalizing those four formulas into a single one, and I'll be calling the length as effective length. Right? So all the expressions for buckling loads with various end conditions which I have derived in the previous four derivations can be generalized as PCR. CR is the crippling load. You can also call it as buckling load is equal to pi square EI divided by L E square. So this is the formula which is generalized and it is applicable for all the four end conditions depending upon the value of LE. Right, so where LE is effective length of the column, I is least moment of inertia about one of the principal axis of the section, and PCR is crippling load or buckling load due to which the column buckles on an axis about which the moment of inertia of the section is minimum. Right, so this is the generalized formula which is used to represent all the four end conditions depending upon the value of LE. Right, so let us go through the effective lengths and let us try to know what is the value of LE in each of the four cases. Right, so for that we need to remember this table. It very important table whenever you are dealing with columns. So following table represents the effective length for various end conditions. So there are four end conditions. First one is both ends are pinned. So there PCR, that is buckling load, is equal to pi square EI divided by L square. This I already derived. Now in this case, if you compare this with the formula which I told you just now, so pi square EI divided by L square, you need to compare it with this one, pi square EI divided by LE square. So if you compare both the things, simply what I can write, I can write effective length is equal to L. Effective length is equal to L. Right? So, or you can write here L effective is equal to L. Similarly, the second case, pi square EI divided by 4L square. So this you need to compare with the generalized formula which is pi square EI divided by LE square. So if you compare both the things and find out the relation between LE and L, I'll be getting LE is 2 times the length. LE is 2 times the length. Similarly, in the third case where I am getting 4 pi square EI divided by L square. This if you compare with pi square EI divided by LE square, and if you try to find the relation between those two, L and LE, then I'll be finding L effective is L by 2. And the fourth case where it was 2.025. Okay, that 0.25 I have neglected since it was a small value. So it is 2 pi square EI divided by L square. This once again, if you are comparing with pi square EI divided by LE square, then I'll be getting the value of L effective as L divided by root 2. Right, so these four things are very important and you need to remember this for various end conditions. Only then it is easier for us to go with the numerical part whenever we are solving a problem using Euler's formula. Right, so that is the concept of effective length. It is simply used to make things precise. Instead of remembering all these four formulas, I'm going to just remember that one general formula, and in that general formula I'm going to vary the value of L effective so that I'll be getting different end conditions as desired. Right, so that is the entire motto or intention of getting this generalized formula and introducing the effective length. Right, so once if we are done with this, next will be going for derivation of Rankine's formula for columns. Okay, so next topic, as I told you, it is derivation of Rankine's formula for columns. Right, now in our very first video session I told you that there are three types of columns: short columns, long columns, and intermediate or medium columns. Right? So for long columns, they fail due to buckling. Right? I told you because the length is more, the compressive direct compressive stress which is applied on the top, its effect is very negligible when compared to buckling. That is, the more dominant in that case is buckling, and that is the reason long columns fail due to buckling. When it comes to short columns, they fail due to crushing due to direct compressive stress. Right? So they fail due to crushing. Why due to crushing? Because since the length of the column is very short, buckling will be very less, and the direct compression due to the load which is acting on the top will be more, and that is the reason the column gets crushed. Right? So that is the reason they fail due to crushing. Next is intermediate or medium columns. Now here they fail due to a combined effect of buckling and direct compressive stress or load. And so these are the three columns which we had studied in the classification of columns, and these are the failure criterias. Right? Now, thing to be observed here is our Euler's formula, what we have derived previously, that are the four end conditions. So in the assumptions itself, I told you that those are only applicable for long columns. So that is the limitation of Euler's formula. Right? So then the question arises, if it is only applicable for long columns, then what should I do if I want to calculate the data related to short columns and intermediate bar medium columns? Right? अब हमें क्या करना चाहिए? That is the biggest question which is going to arise. Now the answer for that is I'll be using the Rankine's formula. Right? I'll be using the Rankine's formula. Right? So why I'm telling you all these things, you should know when you are going to use the Rankine's formula and why you are going to use the Rankine's formula. The reason is simple. The previous four formulas which I have derived, which I call them as Euler's formula, those are only applicable for long columns, whereas when it comes to short columns and the intermediate columns as well as long columns, so for all these things, if you want to take into consideration and find out the deflections and the type of loading, it may be buckling load or it may be crushing load, then we need to go for Rankine's formula, which takes into account all the three columns and we'll be getting the correct values. Right? So that is the significance of Rankine's formula and the reason why it was developed. Right? So now we'll be starting with the derivation of Rankine's formula. So before I could start, let me write here the Euler's formulae derived previously are applicable only for long columns. Thus, Rankine, thus Rankine and Gordon, Rankine and Gordon came up with a formula which is applicable to came up with a formula which is applicable to short, medium, and long columns. Right? The Rankine's formula is given by the Rankine's formula is given by so it is 1 divided by P is equal to 1 divided by P is equal to 1 divided by PCR plus 1 divided by PC. Right, so this is the Rankine's formula. What are these terms? I'll tell you in a while. Where PC is given by sigma C into AC, and it is called as crushing load. PC is crushing load, and PCR is given by pi square EI divided by ELE square, and this is buckling load, right? And obviously 1 by P or P is nothing but the total load, because it is taking into account both buckling as well as the direct crushing load or compressive load, right? Where AC is the cross-sectional area of the column, where AC is the cross-sectional area of the column. So this equation 1 takes a specific form depending upon the length of the column. Right? So how exactly it is going to vary, I'll show you now. So this is my equation number 1. Now I'll be taking 3 cases. First one for long columns, then for short columns, then for intermediate columns. So for long columns, what we observe is the value of crushing load is very large. Right? The value of crushing load is very large. Value of PCR is very large, which implies that which implies that 1 divided by PCR is very small. Thus, equation 1 in this case will be reduced to, in this case it will be reduced to 1 by P is equal to 1 divided by PC. Right? So that is how Rankine's formula is reduced for long columns. Okay, next there is a small correction, pardon for that. So this is for short columns because I am taking the crushing load. I told you PCR is crushing load, where crushing load will be very large. Crushing load is nothing but the direct compression. Direct compression will be large for short columns, right? Because that is the main criteria of failing in short columns. So I had committed a mistake, sorry for that. You please correct this. It should be for short columns, value of PCR is very large, which implies that 1 divided by PCR is very small. Thus equation 1 in this case will be reduced to 1 by P is equal to 1 by PC. So next we'll be going for second case, that is for long columns. Long columns. Now here what we observe is value of PC is very large, which implies that 1 divided by PC is very small. Therefore, equation 1 becomes 1 divided by P is equal to 1 divided by PCR. Right? So this also you can write it in other way. If you just take the reciprocal, you can write it as P is equal to PC in this case, and in this case you can write it as P is equal to PCR. Right? So as we had studied in the first table in the first video lecture, so for long columns you are having buckling load or crippling load which is predominant, and for short columns you are having the direct compressive load or crushing load which is predominant. Right? Next, the third case. So third case is very important for us. So third case is for medium columns. For medium columns. Now here this is subjected to a combined effect. Thus I'll be directly using this formula itself, since these are subjected to a combined effect of buckling and crushing. Equation 1 becomes, okay, so what is our equation 1? Our equation 1 is 1 by P is equal to 1 divided by PCR plus 1 divided by PC. So you just take the LCM, it is 1 divided by P is equal to PC plus PCR divided by PC into PCR. Right? I have taken the LCM. Taking the reciprocal of this, so if I just take the reciprocal of this, P is equal to PC into PCR divided by PC plus PCR. Right? So this is what I am getting. If I just shift that PCR into the denominator, if I shift this PCR into the denominator, so therefore P will be equal to, PC will remain as it is in the numerator. So if I shift this PC plus PCR, entire thing is divided by this PCR, which is coming PCR. Right now, no changes I have done. Only this PCR which was there in the numerator I have shifted to the denominator. Value remains same. It is A divided by B by C. So it is A into C divided by B. If we simplify, you will be getting the same expression once again. Right? So this you can write it as PC as it is divided by PC divided by PCR is PC divided by PCR plus 1, because PCR and PCR will be dividing and its value will be equal to 1. Right? Now here I'll substitute few things which are very important for us. Okay, now in this formula I need to substitute. We know that I have told you in the initial stage of this derivation that PC, that is crushing load, is equal to sigma C into AC, right? And PCR, crushing is crippling, is equal to pi square EI divided by LE square, right? So this we have dealt with in the initial stages of this derivation. So you please substitute this into this. Substituting, we get substituting we get so P is equal to value of PC is sigma C into AC divided by value of PC is once again sigma C into AC, where AC is cross sectional area, divided by PCR is pi square EI divided by LE square plus 1. So this is what I get. Now where I is equal to I minimum is equal to A into AC into K square. AC into K square, right? Where K is called as a radius of gyration. Radius of gyration. So therefore, I will be substituting the value of AC into K square, that is the value of I in this formula. So let me check out what I'll be getting. So therefore P is equal to sigma C into AC divided by sigma C into AC plus 1 divided by pi square E. Value of I is AC into K square divided by L effective, the whole square. Right? So this is the value I get if I put I is equal to AC into K square. Now यहाँ पे जो कुछ भी cancel हो सकता है, I request you to cancel it directly, right? So I can take one more step just to simplify, because you may get confused. So sigma is P is equal to sigma C into AC. So the entire thing is divided by, so it is of the form A divided by B by C, right? So how you can write this? You can write it as sigma C into AC divided by pi square E AC into K square, it multiplied by this LE square goes to the numerator, right? Plus 1 will remain as it is. Now you cancel the terms. So AC and AC are going to be cancelled. Right? After that, so to simplify this, what I'll write, put sigma C divided by pi square e is equal to a. So if you put this in this equation, so it implies that the value of p will be sigma c into ac divided by sigma c divided by pi square e is nothing but a. I'll be getting le square divided by k square plus 1. Right? So slightly simplifying this final equation, what I'll be writing, therefore p is equal to sigma c into a divided by 1 plus a. Both are squares, so I'll be writing it as le divided by k, the whole square. Right? So this is the Rankine's formula, which can be used for short columns as well as medium columns, whereas for long columns we are always having the Euler's formula which can be used. Right? So that's it for today's session. Have a good day. Take care. Bye bye.